So in this video we shall be discussing about the next phenomena, which is called as coning of wheel. Now before we begin with the discussion on coning of wheel, you need to understand the basic structures that are involved in, or basic components that are involved in a wheel section. So imagine that you might have seen lot many trains moving around, and if you have observed that there will be two such wheels attached together with the help of an axle. Okay, so this is the axle, which looks like a shaft, and this and this, so these two are the wheels. Now these wheels are generally metallic, the rails are also metallic, the axle is also metallic, and within this wheel, this particular section, which looks like a plate, the projected portion, is called as flanges of the wheel, right? And then the surface which comes in contact with the rail, or which always remains in contact with the rail, is called as the tread, or tread of the wheel. Now it is always expected that the center of the tread gets aligned to the center of the head of the rail. That is what is expected. Okay, so to keep this particular concept aligned, where the center of the tread of the wheel and the center of the head of the rail are aligned, can happen through a phenomena called as coning of wheel. Now the coning process is very simple. The tread of the wheel, though it might look as if it is flat in our practical observation, okay, so if you happen to see the wheel physically by yourself, then you might not be able to make out this coned section of the thread, but it will be actually manufactured in such a way that it will be not flat, but it will be sloped to some particular slope, and that process of introducing a slope to this tread of the wheel is called as coning, right? So the distance between the inner or the inside edge of the flange, this, the distance between the inner edge of the flanges of both the wheel, will always be less than the gauge of the railway track. Okay, so this clear distance between the inner faces of the flanges of the wheel is called as the wheel gauge, whereas the clear distance from the, or clear distance between the inner surfaces of the heads of the rail are called as the uh, track gauge. So there are two things here. One is the wheel gauge and the other one is the track gauge. Okay, so the process of keeping the center of the tread of the wheel and the center of the head of the rail happens through the phenomena called as coning of wheel, right? That is what I told you. So the wheels will be manufactured in such a way that a gradual slope will be introduced on the tread, which is to be around 1 in 20, right? Now to see to it that this is aligned with that of the the rail also will be tilted to this particular slope of 1 in 20, and the platform on the sleeper, or the section of the sleeper, the top section of the sleeper, which holds the rail and that of the wheel, also will be with certain slope. If you happen to observe the sleepers, you just pay close attention to the section that I am showing. Okay, so the surface of the sleeper which holds the rail will also be sloped to this particular slope, that is 1 in 20, right? So this process of introducing the slope on the tread of the wheel is called as coning, right? And this coning actually helps to see to it that both these centers are aligned always. Though the vehicle might move to the left and right, but after certain distance, the vehicle will be brought back to its position where the center of the tread will be aligned with the center of the head of the rail. Right. Now there are certain advantages of coning of wheels. The advantage is that even if the vehicle moves to the left or right, there will be a gap between the inner surface of the rail with that of the inner surface, outer surface of the flange. So this gap will keep on varying as in how the vehicle moves. The horizontal thrust or the lateral thrust will be moving the vehicle either inwards or outwards. It depends. So whenever the vehicle moves on the either side, the coning will see to it that the vehicle comes back to its original position, and this gap will be maintained properly. Right. So when the vehicle moves on the either side, everything is metallic here, so the flange also touches the inner side of the rail, and there will be a huge amount of friction that will be developed, and that will add to the resistance of movement of the vehicle. Now this friction and resistance is responsible to the degradation of the metal that we use in the construction. So because of this coning, the reduction in wear and tear of the wheel as well as the flange and the inner surface of the rail gets minimized. So that's the first advantage. Then because of this coning process, you will be having a chance of giving a smoother lateral movement of the vehicle either to the right or to the left. Okay, the lateral movement of the vehicle will be free, and it will be not causing discomfort to the passengers who will be traveling within the vehicle. Also, it prevents the wheel from slipping. This coning prevents the wheel from slipping from its original position. So these are the advantages of giving coning to the wheels. Now this theory of coning explains to you about how it works on a level track or a straight track, and that on a curved track. Okay, so on a straight track, if we try to consider, you have a straight alignment as in how the axle moves towards the rail, either it might be an outer rail or inner rail. When the axle moves towards one rail, the diameter of the tread increases on that particular rail. For example, if you take into consideration this particular case itself, the tread diameter is considered to be as less on the outer section of the wheel, whereas when you start coming close to the inner section of the wheel, very close to the flange, the diameter will be the highest. So the diameter of the wheel will be less here, and the diameter of the wheel will be more here. Right. So when the vehicle is say moving to the right, then the diameter of the tread will be more here, and it will be the least here. Okay, so that is what is being told in this particular case. So when the axle moves to one rail, the diameter of the tread increases on that particular wheel. On the other hand, the diameter of the tread on the other wheel, which is joined with the same axle, will decrease. Okay, so this particular process will give instability in the axle, and the coned section of the wheels will see to it that the whole system is brought to its original position, such that the center of the tread of the wheel is aligned with the center of the head of the rail. Right. Now that's the advantage of providing coning, and this is how the theory works on a straight level track. But when it comes to a curved track, okay, curved track, say like how it has been shown in this diagram. Right. Imagine you have a railway track section wherein this dotted line represents the rail, the outer rail, and this represents the inner rail. Right. the inner to inner clear distance between the heads of the rail represents G. This is how the gauge is represented, capital G, right? So half of this G is G by 2 and G by 2 respectively. The radius of the outer rail can be considered as R2 and the radius of the inner rail can be considered as R. And then similarly the center of the alignment, with respect to that the radius is considered to be as R, and this angle is say theta, right, with respect to some center O, okay, for which or through which the curve would be designed. So this being the outer rail and this being the internal rail or the inner rail, this is the axle of the wheel. Okay, it's a typical section that has been taken into consideration. So if we have R1, R2, R, G by 2, G by 2 and G, then on a curved section, when the axle moves outwards towards the outer rail as it was shown in the diagram, uh, the tread or the diameter of the tread on the outer rail will be more than the diameter of the tread that is there along the inner wheel, which is moving along the inner rail, right? So the tread dia is the same for both the wheels in that particular case. I'm talking about only the outer wheels. So when this is the situation, okay, under this particular situation, you can see that the diameter of the tread will be highest in these two wheels and it would be least in these two wheels, right? So if theta is the angle to be considered, then there will be some amount of slip taking place in this particular system, and that slip is said to be equal to theta multiplied by R2 minus R1, right, where R2 is the outer radius, which is R plus G by 2, and R1 is the inner radius, which is R minus G by 2, right, where capital G is the gauge of the track, theta is the angle at center line in the required uh, unit. Here they have taken it as radians. So the total amount of slip or the total slip that is going to take place is theta multiplied by R2 minus R1. So R2 minus R1 is nothing but the gauge of the railway track. So theta times of G will give you what is the amount of slip that is going to take place in the vehicle when the vehicle is approaching a curved section on a railway track, right? For example, in case if we are trying to find out the slip for a broad gauge track, so broad gauge track, as I told you, the gauge is 1.676 meters. It is not. It is either considered as 1.676 or it can be taken as 1.7 meters as well. Now, since theta is in radians, the slip will be equal to 2 pi theta divided by 360 multiplied by the gauge. Now, for theta equal to 1, the amount of slip that is going to take place is 0.029 meters. Okay, so for a broad gauge track, per degree, there will be a slip of 0.029 meters, right? So this is what is the theory of coning. So this is the indication that even if you are trying to provide coning in the wheels, there will be some amount of slip taking place. Even though the vehicle is being tried to pull back because of coning, just because it is having a lot of lateral thrust, okay, because of the angle that is being provided to design a curve, right, there will be some amount of slip taking place. So coning of wheel is considered to be of not much advantage when we are talking about a curved section of a railway track. That's why this again induces lot of pressure on the outer rail. It is observed to wear the outer rail too much, and the gauge also tends to increase due to the widening tendency because of the lateral thrust. right? The gauge starts increasing, the track gauge starts increasing, and also you might have to provide additional components to see to it that the track is rested intact on the system. Now, to avoid this kind of a thing, we provide something called as tilting of rails and adzing of sleepers. As I told you, just providing coning of wheel is not enough. You will have to tilt the rail as well, like this, and also there has to be a platform of a slope 1 in 20, okay, which need to be provided on the surface of the sleeper. So this is called as adzing of sleeper. So one is coning to be provided, second is tilting of rails to be provided, and then the adzing of sleepers to be provided. Now all these three will have to be with the slope of 1 in 20. So that is about coning of wheels. Okay, theory of coning, and then alternatives to avoid the wear and tear of uh, rails, sleepers, and then even the wheel. Okay, so this is how the explanation should be given in terms of a diagram, a typical diagram. So you can see there is a coning of 1 in 20 being provided for the wheel. The rail is tilted to 1 in 20, and then the adzing of sleeper also is being given to a slope of 1 in 20. Okay, so this is all about coning of wheel. I think I'll continue with the next part in the next video.